All right, so I'll start with the introduction, and then we can start the talk officially. So thank you again for accepting our invitation to be here. I know all of us know that there's no need to officially introduce you here because we all know who you are. But just to for those audience that do not know you, I will give a brief introduction. So Professor David Nutt is currently the Edmund J. Safra Professor of Neuropsychopharmacology and the Director of the Neuropsychopharmacology Unit in the Division of Brain Science at Imperial College London. He is currently the Chair of Drug Science, formerly the Independent Scientific Committee on Drugs, and President of the European Brain Council. Previously, he has been president of the European College of Neuropsychopharmacology, or ECMP, the British Neuroscience Association, or BNA, and the British Association of Psychopharmacology. In addition, he's a fellow of the Royal College of Physicians and of Psychiatrists, and a fellow of the Academy of Medical Sciences. He's also the head of Center for Psychedelic Research at Imperial College London. He has edited the Journal of Psychopharmacology for over 2 decades and acts as a psychiatry drugs advisor to the British National Formulary. He has published over 400 original research papers, a similar number of reviews and book chapters, 8 government reports on drugs, and 27 books. In 2010, the Times Eureka Science magazine included him in the 100 most important figures in British science and the only psychiatrist. Professor Nutt broadcasts widely to the general public, both on radio and television, including BBC Science, and public affairs programs on therapeutic as well as illicit drugs, their harms, and their classification. So thank you so much for being here, Professor Nutt, and so the floor is all yours.
Well, thank you for the invite, and this is definitely the first time I've given a talk in Iran or Persia, whatever you prefer. And,
hopefully in person, maybe.
Hopefully in the future, yes. Well, hopefully things will get better. So, just a few declarations of interest. I do consult with a couple of companies that are working in the psychedelic space and trying to develop them as medicines. So that's what I've highlighted in red. Those are my possible conflicts of interest. So what are we talking about today? Well, when we talk about psychedelics, we're talking about usually about plant-derived products which work on the serotonin receptor. And some examples here, you see mescaline from the peyote cactus. You see magic mushrooms producing psilocybin, over 200 species of those. Ayahuasca, which is a DMT-containing drink that's used in the Latin America countries, particularly the Amazon basin. Bottom right is the European Caucasus Siberian mushroom, Amanita muscaris. That's different. That's a GABA-containing product, which I won't talk any more about now. And then morning glory, the seeds of which contain an ergot derivative, like the fungus ergot. And the ancient Greeks used to celebrate their art and culture, particularly music and dance, using a combination of ergot and alcohol. And really, that's one of the first examples we have of psychedelic drugs having a major role in culture. But of course, the big impact in terms of what we might call modern medicine, modern science, came with the discovery in the 1940s by Albert Hofmann of LSD. LSD is a derivative of ergotamine. Ergotamine has been used for hundreds of years to help women after childbirth to constrict the uterus, and also as a migraine treatment. But he modified the molecule, made a much longer acting version with very different properties called LSD. And here he is at 100. He used to use it on a regular basis, and he lived to over 100. But LSD really did change the whole understanding of psychedelics because it brought them into Western medicine. And that was partly because of the remarkable impact of LSD, and also because the company that Hofmann worked for, Sandoz, the pharmaceutical company, which is now part of Novartis, they were very open with the product, and they made it available. Here you see LSD being made available as tablets, and also psilocybin. Hofmann discovered in 1958 that psilocybin was a similarly serotonergic acting drug He worked out the structure, and they made psilocybin as a medicine too. And it was used, these drugs were used for 4 purposes: to model psychosis in people, which is something we still do today, to help mental health professionals understand what it's like to have altered consciousness so they can have more insight and empathy with their patients who also feel that their mind is changing, but particularly for psychotherapy. And there were 2 kinds of psychotherapy. And one was called psychedelic psychotherapy, and that was favored in America. And that's the kind of psychotherapy we're tending to do today. You give a single big dose. People have a powerful experience, a trip, often not very pleasant if they're patients, but afterwards they come out with their brain changed. They think differently about their illness and their past and their future. But in the UK, we tended to use lower doses in what we call psycholytic psychotherapy. And that was this is what we would now call a MIDI dose. So for instance, with psilocybin, 25 milligrams would be a maxi dose, a trip dose. We might use 10 or 5 milligrams to produce a MIDI dose. And that's given before psychotherapy, and it's given on a regular basis to facilitate psychotherapy, to break down some of the resistances that people have to thinking differently. We hear a couple of quotes from British psychiatrists who became very interested and popularized psychedelics then in the 60s. Ronnie Lang, who was an anti-psychiatrist, but was in favor of psychoanalysis, he said, if you want to become a psychoanalyst, you should do 3 things: read the works of Freud, undergo personal analysis, and take LSD. And Humphrey Osmond was a British psychiatrist who went to Canada. He was the guy that actually gave LSD to Aldous Huxley, because Huxley had previously used mescaline, and that's the basis of his book, The Doors of Perception. And Osmond said, to think in hell or soar angelic, you'll need a pinch of psychedelic. And it's worth remembering, in those days, in the 1950s, there were no psychiatric treatments other than sedatives like barbiturates and opiates. And people weren't getting better. They were just being essentially kept in this kind of chemical straitjacket, because modern psychopharmacology hadn't started till the 1950s. So LSD and psychedelics were seen as a revolution. They could give us insights into the brain, but they could also heal the brain. And there was a massive amount of research. The drug was made available by Sandow to hundreds of psychiatrists worldwide. There were 140 NIH grants, American grants, 1,000 clinical papers, 40,000 patients were studied, 40 books, 6 international conferences, and the results were summarized eventually in 1971 after these drugs were banned as being overwhelmingly positive, describing safe and effective treatments. And under here you see 4 examples of the treatments, 4 examples of major reviews of thousands of patients, and the conclusion from analyzing all these vast amounts of data is in the yellow box. Treatment with LSD is not without acute adverse reactions. Yes, people can have bad trips, tough trips. Giving psychedelics to people who are mentally ill is not giving them fun. They have to work through a lot of the traumas which led to their illness in the first place. But given adequate psychiatric supervision, which is what we do, and proper conditions for its administration in a hospital or a clinic, the incidence of such reactions is not great. And in fact, if you look behind the box, you see that the levels of psychosis and suicide were considerably less than you would expect from a population that didn't get treated. And in fact, we now know from this work and more recent work that these drugs are remarkably safe in terms of population exposure. And one of the pioneers of this research was a man called Stanislav Grof. And he said this: psychedelics, used responsibly and with proper caution, would be for psychiatry what the microscope is for biology and medicine, or the telescope for astronomy, a necessary tool. But of course, we've been denied that tool for a very long time. And the reason for that was actually the war in Vietnam and the American government becoming concerned that the anti-war movement was being fueled by LSD, concerned by the writings of people like Timothy Leary saying that people should not fight the war, they should drop out. And by that image on the top right-hand side there, drop acid, not bombs. And LSD was seen as producing or supporting or fueling an anti-war culture that didn't fit with the narrative at the time. And they couldn't ban people voting against the war, but they could ban LSD, and they did. And it's been banned now in all countries in the world almost completely for the last 50 years. And what was remarkable is that the ban was effected despite opposition from the most powerful man in America at the time, Bobby Kennedy, who was Secretary of State, who would have been president if he hadn't been assassinated. And he's saying to his regulators, he's saying, look, why, if these clinical projects were worthwhile 6 months ago, look, we've spent 10 years and $2 billion doing research. How come they're not valuable now? He knew the bureaucrats were being deceitful to him. If I could get a flat answer about that, is there a misunderstanding about my question? And he knew that he was being lied to, but even he could not stop the bureaucrats banning these drugs. And the ban now has been endorsed by nearly 200 countries in the world that sign up to the UN conventions. And I think this is the worst censorship in the history of the world. This is the worst censorship of research there's ever been, because it's endured now for over 50 years. Is there ever been anything comparable? Well, the Catholic Church in 1616, they banned the writings of Copernicus. Now, Copernicus was an astronomer who had discovered that the Earth was actually not the center of the universe. The sun was, he thought. And that conflicted with the teachings of the Catholic Church. And they banned his writings, and they executed people that preached his writings, like Giordano Bruno. That ban lasted 150 years. There weren't actually that many astronomers to ban. And it only applied to Catholic countries, Northern Europeans, and I think also in the Ottoman period, astronomers were carrying on studying the skies, studying the planets. So it was a big ban, but it wasn't anything like as broad, as global as the ban on psychedelics. And the ban has had an extraordinary detrimental effect on research. So here you see in blue the number of papers per year published on LSD, and in red on psilocybin. And you can see this massive increase as a result of the NIH funding. And then you can see from the ban in 67 in the US and 71 under the UN conventions, a precipitate fall in research. And there are two reasons for that fall. I mean, firstly, there was no funding. The American government and probably almost no other governments in the world have funded any research on LSD ever since. And the second reason is that even if you could get funding to do the research from, say, charities, the regulators made it virtually impossible to get hold of the drug because they said it was too dangerous to use. And there was an attempt, I believe, to eliminate all knowledge of these drugs, which of course would have been disastrous. But luckily, you can see now the tide is turning and research is picking up. If you want to read more about the history of the banning, here are a couple of papers that I've written. And I've sent all the slides through, and you can all have the slides afterwards for your personal use if you want. You can look at these papers. But I want to focus on what we've been doing now in the last 15 years, fighting back, trying to resurrect scientific interest and knowledge about psychedelics. And I've done it with the Imperial College largely now, and with the Beckley Foundation. So we started off by asking the question, what is a psychedelic trip when you take magic mushrooms? And there's some magic mushrooms, Liberty Cat mushrooms. Now, as I mentioned earlier, all the psychedelics except Amanita work on the serotonin 2A receptor. Their clinical dose is completely predicted by their affinity at the 5-HT2A receptor. The highest affinity drugs like LSD, you have very low doses. Psilocybin here, you have a moderate dose, and mescaline, you have a much bigger dose. So that proves that these drugs do work through that receptor. And of course, subsequently, people have shown that if you block that receptor, the effect of these drugs is in itself blocked. So where are these receptors? Well, they're in the brain, and they're really heavily expressed in the most recently evolved and the most cognitively important parts of the human brain. So this is a heat map of the receptors in the human brain. And you can see they're relatively few in the sensory motor cortex, which is why psychedelics don't have much of impact on movement or a sensation. They're relatively few actually in the visual cortex, interestingly, massively expressed in the posterior and anterior cingulate and frontal cortices. And these are the parts of the brain where you do your very high level. This is the parts of the brain where the vast capacity of the human brain for thinking, planning, analysis, creativity takes place. So these receptors really are linked to the very high level cognitive functions of the human brain. Very, very few you see here in the midbrain and brainstem. So about, over 10 years ago now, we did the first study. We gave people who had previous experience with psychedelics, we put them in an fMRI scanner, we gave them psilocybin, and they had a range of experiences. They saw the elementary hallucinations, the colored lights, moving shapes, etc. Many of them had a sense of ego dissolution. Some of them floated out of the scanner, and one went to heaven and bowed at the foot of God. It was a powerful experience for most of them. And we thought that we would see profound increases in brain activity that related to these experiences. But to our amazement, we found the opposite. We found just decreases. And for those of you who aren't familiar with these kind of fMRI measures, blue is less activity. And we found that psilocybin switched off activity in the anterior and posterior cingulate cortices, those areas of the brain where the receptors are most dense. They also switched off activity in the thalamus, which doesn't have receptors, and that's a reflex effect coming down from the cortical regions. So we scratched our head and said, well, have we done the experiment wrong? And we repeated it using a different kind of analysis. This was fMRI bold. Sorry, this was fMRI, this was arterial spin labeling. We then did a bold measure, and we found exactly the same thing. And then we realized that the profits, the psychedelic profits in the 1960s and 50s, particularly the 60s, people like Leary were wrong. These drugs don't turn on the brain. They actually turn off the brain. And it's that turning off the brain that turns out to be particularly interesting. And one of the areas of the brain they turn off is this frontal region of the brain called the anterior subgenual cingulate cortex. It's in that yellow circle there. Now, when we discovered that, we were quite intrigued because we had known by that point, by 2012, many studies, they're in the green box there, many different treatments of depression were all associated with a reduction in activity in that brain region. In fact, it's that brain region which drives a lot of the negative thinking of depression. And if you get better on SSRIs, on CBT, on ECT, even on placebo, if you get better on placebo and you scan the brains afterwards, there's reduced activity in this brain region. And another psychedelic, ketamine, was also shown to do the same thing. So we thought, wow, if we can switch off that brain region, maybe psilocybin would be antidepressant like these. But the other really interesting aspect that led us to start working in depression was the impact that psilocybin had on what's called the default mode network in the brain. Now, I need to explain that to you because not everyone will understand that. It's called the default mode network because it's the brain circuit which is active when you are not doing things other than thinking. So we're going to activate each of you now, we're going to activate your default mode network now. So what you're going to do is when I stop speaking, you're going to close your eyes and you're going to reflect on what interested you about the prospect of this talk today and what you might do with the data I've shared with you so far. So I'm going to stop talking and you just close your eyes and just ask yourself that question in your mind. Why did you come and what did you think you might gain from it? Okay, you can open your eyes now and listen to me. Now, if I'd scanned your brain during that experience, I'd have shown an image like this top left image here. the most active parts of the brain when you were doing that internally focused thinking would be the anterior and posterior cingulate cortices, shown here and shown here, and also these lateral parietal regions, because you were doing nothing else. The thinking parts, the parts of the brain which do your thinking about yourself, are these network called the default mode. And when that's active, when you're not moving, your motor strip's switched off and you're not seeing things, you've closed your eyes, your visual cortex is switched off. So this is the part network which encodes your self-referential thinking. Now look what happens under psilocybin, the bottom images. That network disappears. It's fragmented. And that explains why people have ego disillusion, why people feel that they floated out of the scanner, because their sense of where they are is completely disrupted, because that's encoded in this network. What's that got to do with depression? Well, about the same time as we were publishing our data, this group were publishing data on the default mode network in depression. And look here, you see, in depressed people, much more of the brain is connected in that default mode in depressed people than in people who are not depressed. And this has huge implications. It explains why depressed people really struggle with cognitive tasks, because if you're spending or using large chunks of your brain just thinking about yourself, you've got less capacity to do concentration, to pay attention, to read, etc. So that's the first thing. The second thing is that hyperconnectivity is driven by overactivity in this region I've shown you before on the previous slide, the subgenual cingulate cortex. And this connectivity of this to this predicts rumination, that repetitive thinking that depressed people get locked into, they can't escape from. And so we thought, well, if depression is a disorder of overactivity of the default mode, then if we can disrupt that with psilocybin, maybe we can treat depression. And so we did a study. We were encouraged to do that study by the work of Roland Griffiths and team in Johns Hopkins, who'd shown that in non-depressed people, the same dose of psilocybin could produce quite long-lasting benefits in terms of a sense of value and meaning to life. And we wondered if there would be an antidepressant effect from psilocybin. And we actually managed, the only time ever in the last 15 years in this field, to actually get any money from our government to do research. But we got funding to do research in resistant depression because, of course, that's a major, major problem. It's in Western society, it's one of the biggest health problems of all. We got a grant, but it took a great deal of trouble getting the drug, getting ethical approval. And all the burden of doing this was driven by the fact that this is a controlled drug under the UN, and it's controlled as much more harmful than drugs like heroin or fentanyl, which of course are more harmful than psilocybin. But the international conventions really do make it very hard. It took us 32 months out of a 36-month grant just to get the drug. Cost huge amounts per dose. But we did it, and the results were remarkable. So all these people had resistant depression. They'd all failed on at least 2 antidepressants. Some had failed on 10. They'd all failed on CBT. And within a day of having a single dose of psilocybin, 25 milligram dose, their depression scores had halved. And some people were in remission, and they've stayed in remission for 8 years. The majority, the depression has come back, but even at 6 months, there was still a very powerful antidepressant effect. And this is the most powerful treatment of resistant depression there's ever been from a single dose of a drug or a treatment. So what is it doing to people's minds? Well, it's changing the way they think. So before the administration of the psilocybin, we rated people on the scale of optimism and pessimism, and depressed people have what we call a pessimism bias. They see the world as a hostile, nasty, challenging, threatening place. Actually, they're right, it is. But that doesn't help. If knowing the truth about the world actually makes you more depressed. Most of us have what we call an optimism bias. And you can see after the psilocybin treatment, we didn't make them optimistic, but we did at least get rid of the pessimism bias. And here's a quote from one of our patients. "My outlook has changed significantly. I'm now more aware it's pointless to get wrapped up in endless negativity. I feel as if I've seen a much clearer picture." And this is very characteristic of the kind of insights that our patients give to us. Here's another one. Let me read this. It was like when you defragged the hard drive on your computer. I experienced blocks going into place, things being rearranged in my mind. I visualized as it was all put into order. A beautiful experience with those gold blocks going into black drawers that would illuminate. And I thought, my brain is being defragged. How brilliant is that? My mind works differently now. I ruminate much less, and my thoughts feel ordered, contextualized. Rumination was like thoughts out of context, out of time. Now my thoughts feel like they make sense with context and logical flow. So you can see the profound change in thinking processes that these drugs introduce. And I would recommend, if you can, read this journal, this article, which goes through many of the narratives, and they're very moving. So then we ask the question, well, is the antidepressant effect of psilocybin the same or different from that of other antidepressants? And so we did a comparative trial, a head-to-head of psilocybin, 2 doses this time, 3 weeks apart, with escitalopram, the gold standard SSRI. And we looked at outcomes, efficacy, and we also looked at brain imaging. And now, it was quite a difficult study to blind. The way we did it in the end was tell everyone they were going to get psilocybin, and they did. But half the group got a high dose twice and had 2 trips, and the other half got a low dose, didn't have a trip. But the low dose group, they was then put onto escitalopram for 6 weeks. But they all got the same psychotherapy around the psilocybin administration. So they got psychotherapy preparation for the trip. People were present during the trip, and they had this psychotherapeutic intervention and integration the day after the trip and other episodes of the periods following the trip. We were interested in side effects, and it turns out there was really little difference in side effects over the 6 weeks between the 2 groups. And then we looked at efficacy, and all these measures, the green bars, show significant benefits of psilocybin over escitalopram. In fact, on every measure, with the exception of the self-report quiz scale, they all were significantly in favor of psilocybin, so supporting what we'd found in that previous study. And what was remarkable was that remission rates were very much higher. You can see, depending on which scale you use, the self-report, QIDS, or BDI, remission rates were 2 or 3 times that of the SSRI, and the same on the doctor-rated scales, 2 or even, almost 4 times higher on the Hamilton scale. So the psilocybin is more likely to get people into a state of complete recovery. Now here's the time course of those effects, and you can see what happens when we give the second dose at 3 weeks. There's relatively little impact on the psilocybin, the red group, probably because they've reached a floor effect here and a ceiling effect here. But you see this very immediate and powerful effect of psilocybin to improve not only depression, but also to improve well-being. And it may be this well-being gives people a more enduring resilience as in recovery. Now, we're not the only people to have worked in this field. There are groups in the States that have looked at psilocybin for people who've been given a terminal diagnosis, like a terminal cancer or terminal neurological disease, and they've shown efficacy. Last year, a group in Johns Hopkins did a comparison of psilocybin versus no treatment in depression and showed psilocybin was very effective, and that if you took the no treatment people and then switched them, it was also effective. There have also been trials in conditions like smoking cessation and alcoholism, which have shown efficacy. And we're currently halfway through a trial in OCD, and we're setting up trials. We're halfway through a trial in anorexia, and we're also setting up trials to start in OCD and in pain syndromes quite soon. And you might say, well, why are all these disorders likely targets for psilocybin? And I believe it's because they're internalizing disorders. They're all disorders in which people get locked into thinking processes which they don't like, which they find actually quite destructive, but from which they can't escape. And I think psychedelics allow people to escape from rumination. So how do they do that? What are the brain mechanisms? Well, our imaging studies and now a lot of preclinical work has shown that the impact of psychedelics is on neurons in the cortex called the layer 5 pyramidal cells. And by stimulating these, you get a profound depolarization of these neurons. And I'll explain in the next slide why that's important. But that depolarization produces a state of very disorganized brain activity. Normal synchronized brain activity becomes very entropic, very disorganized. And as a result of that, we break down the control centers that limit brain function. And so we get increased connectivity. So the brain goes from what we call the small world brain state, when people are locked into a relatively limited flexibility, to much more flexible thinking during the trip. And this is a very beautiful image. It magnifies what I've just said. Under psychedelics, connections in the brain which have actually not existed since you were a baby are allowed to re-exist. One of the fundamental processes of brain development is to take a brain which is hyper-connected and limits its connections to things that are really useful, so that when you all know what the same word means, you will do the same things when you want to eat your food, etc. But this shrinking of brain connectivity, it comes at a price, and it comes at a price that some people's brains can get locked into a very narrow repertoire of activity, which can be broken down by psychedelics. And let me talk you through this in the context of using vision as a context, because this is where we have very good understanding of what goes on. Your brain is not a camera. What you see, looking at me now, is an interpretation of what your brain thinks is out there based on electrical impulses coming up from the retina and going into a large amount of the posterior parts of the brain. And those visual cortex regions take those electrical impulses and recreate an estimate of what's out there. And you've worked out that it's me because you knew it was going to be me. And after having seen that it was me in the very beginnings of this talk, your brain won't bother to update that, because I won't change. I can't change. Then you know I'm going to be here for an hour. So your brain is very efficient because it makes a prediction which is usually right. But that efficiency of the brain comes at a cost. It comes at actually not really caring much about things that aren't important to the brain. And there's a wonderful quote from the British painter and mystic called William Blake, who said that people tend to see things in a very limited way, as if they're looking out through the chinks of a cavern. They just see a small percentage of what's actually out there in the world. And he's right, really. Only people like artists and painters see it differently. But for most of us, when we look out through the chinks of our cavern, we see a blue sky and we see white clouds. It's quite a pleasant image. But for depressed people, when they look out, they see a grey, miserable world. And for addicts, when they look out, they see their love objects, the bottle or the syringe or the white powder. And that's because over time, your brain determines how you view the world. And there's another wonderful quote from Blake, which talks about humans having mind-forged manacles, that the brain makes a decision as to what's out there and locks you into it. And psychedelics disrupt that process. And that's why people have hallucinations, why the visual system becomes very different. Because if you cannot build up the image that's out there, then your visual system is still active. And that's why you get those very interesting elemental hallucinations. The same thing goes for higher parts of the brain, where people create interpretations of the world which lead to delusions or misperceptions in conditions like depression, where people start to believe that they're guilty, even though they're not. And the breaking down of the ability of the brain to create false perceptions is, I think, how psychedelics break the manacles that the brain puts on the mind. And here's a visualization of this that's published just yesterday in Nature Medicine from our work. So this is the consequence of imaging people with depression before and after the treatment with psilocybin. And these are maps of connectivity in the brain, or the likelihood of different parts of the brain connecting with each other. And here in depression, you see the brain is got a very deep topography. There are deep valleys and deep high mountains. And if people get locked into negative thinking, it's as if they're in this valley here. And it's very hard to get out of that valley and think differently. Psychedelics completely flatten that landscape. That's the effect of the entropic brain, so that thinking can be much more fluid during the trip. But after the trip, we showed that the depressed people's brains don't go back to it as being as up and down as they were before. The landscape is flatter, and that facilitates more flexible thinking. And that, I think, is why depressed people can escape from depression as a result of a psychedelic trip. And I just want to finish by another quote from another great writer and philosopher, George Bernard Shaw. Those who cannot change their minds cannot change anything. And what we have seen is that psychedelic treatment can change the minds of our patients. It does it through changing their brains. And what I hope is that we can now use this scientific understanding of how psychedelics work to change the minds of our politicians and our drug regulators to make these drugs available, at the very least, for medical treatment and research, because they are, I think, a revolution in the treatment, at least of depression and possibly in other mental health disorders. So I'll stop now, and I'll just give you the last slide and thank the people that have done the funding, my team in the Psychedelic Center, the family of this man, a young man who committed suicide in his 20s. His family funded the trial against escitalopram to see if we could make better approaches to treating depression. Okay, so I'll stop and got 15 minutes for questions.
Thank you so much for the super interesting talk, and for providing us with the most recent evidence, like the Nature Medicine paper published yesterday. And so I'll just ask the audience to ask their questions. They can use the chat box. So if you allow me, because some of our audience might be a bit shy, I will just say in Farsi that if they want to ask their question in Farsi in the chat box, and I will refer it to you. So I'll just tell them. Yeah. دوستان اگر سوالی از پروفسور نات دارین میتونین به زبان فارسی توی چت باکس بذارین. من براشون در واقع ترجمه میکنم و بهتون برمیگردونم. اگر سوالی هست یا کامنتی هر چیزی هست میتونین توی قسمت چت بذارین. مرسی. All right, so just we're waiting for the audience questions, but there is a question that I have myself, and I know that it might not be quite crystal clear the response to this question, but my question is about the potential bad trips on psychedelics. So you said that the taking psychedelics, especially psilocybin, decreases the default mode network activation, and in turn the self-referential and rumination kind of thoughts in most of the people, at least. So we all heard that some of those who take psychedelics tend to ruminate more, and the bad trips that they tend to get bad trips, but we say. You said that some mental issues might be the reason, underlying mental issues. But what do you think about it? Why do people get bad trips while taking psychedelics?
Okay, so there's two really important things to say here. So let's distinguish patients from healthy people, okay? Let's look at the patients first. One of the important things about our therapy is that we prepare people that the trips are challenging. If you've been depressed for 20 years, there's an awful lot of unpleasantness in your mind. If your depression's caused, as it often is, by childhood abuse or neglect, there's a lot of negative legacy. Going back into that in the psychedelic trip is really challenging. So I don't think we can call them bad trips, but they're challenging trips. People are just in the same way is if you go back into your childhood without a psychedelic. If you've been traumatized, or if you've got PTSD, reliving the experience, which you need to do to get over it, is not easy. So the trips are challenging, but they're rewarding in the long term, because you can break down a lot of the misconceptions and break down a lot of the rumination. So that's on that side, the therapeutic trips are challenging, but they end up with a good outcome. Now, when people use these drugs for sort of self-experiential reasons to understand that there's more of their mind and the capacity of their mind, some people do have bad trips. Those are usually related to anxiety, often related to the fact that they think they might be going mad and they wonder if they're going to recover. Now, overall, most people trips, when even bad trips, don't lead to an enduring effect. They might not want to take the drug again, which makes sense. But, you know, a lot of people don't want to, once they've jumped out of an airplane doing a parachute jump, they don't want to do that again, you know. So bad trips can stop you doing it again, but normally they don't have much enduring effect. The real risk actually only comes from people who have got a predisposition to psychosis. So we exclude people who've been psychotic, who've got a first-degree family relative with psychosis, because there is a danger that you might trip someone into psychosis. They were probably going to get there anyway, but you might accelerate that onset. So we try to avoid people with psychosis.
But there's no evidence that the trip could exacerbate the psychotic symptoms in long term. Is it, or no? It's just in when they're.
It's a good question. I mean, one of the remarkable things was when we got 40,000 patients in the 50s and 60s, mostly given LSD, the rates of psychosis were actually less than in the population. So it might be even protective, but I'm not going to say that. It doesn't seem to produce population level changes in psychosis. I think we can say that.
Right.
There is this other condition called hallucinogen persistent perceptive disorder. People often see sort of flickering lights at the edge of their visual system. We've looked in that. We've done 200 administrations of psychedelics now. None of our subjects or our patients have had that, but some people do report it. And to be honest, it doesn't impair your vision. It does, but people often worry about it. People often email me and say, I've got this flickering. Is my brain damaged? And the answer, no, your brain's not damaged. You've just slightly distorted the integration of your visual system, probably, or it might even be a retinal thing. It isn't going to impair your life, and it generally goes away.
Thank you so much. So that's very interesting about, the anecdotal experience as well. So there are also some other questions in the chat box that I'm going to read out to you. Someone asked that, can we consider trips as altered states of consciousness, which might act as a loophole for people who got stuck in their brain rumination? Can this be a perspective of future consciousness research? That's a rather broad question.
No, I think I didn't show you the slide, but I think the psychedelic state is a fundamentally different and interesting state of consciousness. And I think you can't really study consciousness without using psychedelics. You should use there are other drugs as well you can use. So I think there are two dimensions of consciousness. There's the classic one, which we're all in now, which is the glutamate consciousness, where everything that we see and remember and think is due to glutamate neuronal activity, and that's what I call that's phenomenal, because that produces not just memories but also this wonderful state of what I call parcellation. The precision in which you have laid down information in the last 45 minutes for me is unbelievably powerful, and it's all driven by glutamate. So that's that axis. The other axis is the serotonin axis, the serotonin 2A axis, the psychedelic axis. And when you take a psychedelic, you don't impact on the memory at all, but you change your perspective. You get a different valence, and things become much more integrated conceptually in the same way. And that's why it's so interesting, the imaging. Your conceptual integration is actually mirrored by and probably driven by the fact that you've got more cortical integration. So yes, I think I highly recommend psychedelics as a tool for consciousness research. Yes.
Great. So I don't know if this is my internet connection that is. So can you hear me?
I can hear you. I'll turn off my camera in case it's mine. So maybe I'll turn off the picture. No, you've got the pictures at your end, haven't you? Can you still hear me? Hello? Hello? Can you still hear me? No, I think they've gone.
Hello.
Are you back? Can you hear me?
Can you hear me?
I can hear you. Yeah, I can hear
Sorry,
you.
I think I lost you for a second. I'm so sorry, but
No problems at all.
Yeah, sorry. So just to wrap up with the last questions. Yeah, I'm sorry. So it's great that you can hear me. So there is another question that I think you covered. You can hear me, right?
Yes, I can hear you. Absolutely.
Hello.
Yeah, I can hear you. I can hear you.
Yeah, I'm sorry. So there's another question that I think you kind of covered, and it's yeah, and it said and it says that how can you overcome the fear of a past bad trip? So it's something that I think you kind of covered when answering to the first question.
Well, the answer is very straightforward. If you've had a bad trip, you probably haven't damaged your brain. You've learned something about yourself. You've probably got insights into the fact that you were worried about something. Bad trips are associated with being anxious, but if you haven't damaged your brain, so that's the main thing to be reassured. It's you've had an experience the same way as you might have a fearful experience, but it won't have damaged your brain, and it's you should just accept it as something that you've learnt and just move on. Hello, you still there? Hello? I'm not hearing you at all, I'm afraid.
All right, I'm sorry. I see you frozen. All of my R packages are trying to update themselves. So that might be the reason that I'm having some connection problems. I don't know why the R packages are going to do this right now. But just thank you for your response. And so there are many comments here trying to thank you and thank you for your great talk. But there's also another question that we can, I think we have a few more minutes to have an answer to these questions. Someone said that thank you so much for this profound talk. It is an honor to meet you here. I was wondering, what are your personal thoughts on using psychedelics by clinicians and therapists, and especially theorists on consciousness? Thank you.
Oh, so, well, as I say, I think psychedelics will be the next big revolution in psychiatry. Whether or not therapists need to have had them in order to be therapists is an interesting question. I don't think you could ever compel someone to have them in order to be able to use them. I think that would be unethical. Of course, there's also a problem, and if you insist on therapists doing something that's illegal, then you're also putting them at professional risk. So I think at present we should just allow people to use them as long as they're properly trained without necessarily having to have personal experience. But of course, if once it's up to them, it has to be. You can't we don't expect oncologists to have to take cancer treatments to be good oncologists. So there's no reason why psychiatry should be treated differently. But I do think psychedelics, are an area of enormous importance in neuroscience. And one thing I didn't mention, but I should say now, is that the impact of psychedelics to promote neuroplasticity is, I think, one of the reasons why you may get such long-lasting beneficial effects from a single dose, because not only can it make you think differently, escape from your depressive ruminations, but the plasticity can help you lay down new ways of thinking, which are positive and become enduring as a result of the increased synaptic growth and number of synaptic spines, etc., which psychedelics seem to produce.
hope you can hear me again.
Yep, I can hear you.
So thank you so much and for this response. And here comes the last question here that asks that what must happen to change the stance of the UN? Is there hope for these drugs to be used legally in countries like England or in Iran or other parts of the world?
Yes, well, the UN is very difficult to change because you have powers in the UN, particularly like Russia and China, which are very anti-all drug, and they really are, you know, countries like China and Russia don't even allow opiate therapy for opiate addicts. I mean, they're very, very hostile to drugs. What we need, of course, is to get liberated, rational countries to have basically a campaign to allow these drugs to be medicines. I mean, you don't have to make them recreationally legal, but what you need to realize is that the ban on them being used, the ban was instigated to try to stop recreational use. It didn't do that, but it stopped medical use because doctors have to comply with the law. All we have to do is get the UN, initially the WHO, and then the UN to agree that there are medical value, certainly in something like psilocybin. There's so much data now. There's probably 1,000 patients now we can show have benefited from psilocybin. You know, how can you argue it's not a medicine? And if they would simply to take it out of Schedule 1 of those UN conventions, it would make life so much easier for all of us. So, you know, and if you can persuade your government to support that, then, you know, there's a lot of work going on in Europe. There's an organization specifically targeting that, and I'm part of it. So, you know, if you guys want to join, or if you think your government might be sympathetic, then let me know.
Yeah, sure, of course. So thank you. So that's right. That's something that should happen in a stepwise manner, like just first trying to liberalizing psychedelics for research, and then you're not going to, you know, of course our governments are not going to make it make it legal for recreational use all in once, and just research should be.
But Parmia, can I ask you a question?
Yeah, sure.
I'm not entirely clear of how psychedelics are viewed by the Quran, or presumably they weren't talked about in the Quran, but presumably there's been some subsequent commentary on it by your religious leaders. How do they relate to Islam, psychedelics?
Yeah, so I'm not sure whether there are any, you know, not the psychedelics, you know, all the drugs that alter the state of mind are commonly viewed somehow negatively, and you know, in our country and some other countries as well, based on religious views, but not specifically psychedelics are discussed.
Right.
So there is like a neutral view. It's illegal, but
Yeah.
you know, the past few years, and since this is the one of the first events that people are here trying to talk about the scientific aspect of that, and not the potential abusive potentials of the drugs. So but in Iran, people are trying to figure out that these drugs might be different, whether they have abusive kind of potentials.
Well, no, they don't. It's very important message, because people assume because they're in Schedule 1 of the UN conventions, they are very addictive, but they're not addictive. They're anti-addictive, which is why they're being used to treat addiction.
Exactly.
And you know, and I know that, you know, Iran has an enormous problem with opiate addiction.
Yeah, and, exactly. Yeah, of course.
These could be a major opportunity to treat that.
Yeah, but we're let's see what will happen. We haven't started yet, but yeah, but I hope that your science will bring more information and better insights for the policymakers and the people as well, because the culture, people might have some negative attitudes toward that as well. So people and policymakers should maybe change the attitudes based on the science and scientific evidence, and then see maybe things will change.
That's what I think, and good luck to you. And if I can help in any way, let me know. Okay.
Of course, of course. Thank you so much for the time and effort and all the things that, and thank you so much for the comprehensive answers to our audience questions. And I know that our audience know where to find you because all over the internet they can find your email and everything. Yeah. So thank you so much for the time and everything. And goodbye. Have
Thank
a
you.
great day. And thanks for
And you.
accepting our invitation. Thank you.
It's been a
Bye
pleasure.
bye.
Take care, all of you.
Thank
Good luck
you.
in your
You
research.
too. Bye bye. Bye.
Bye bye.